Alright, this is the second video on section 3.2, and we're going to look at example number 4. We're going to solve the IVP, where r double prime of t is equal to negative 4 cosine tj minus 3 sine tk, and r prime of 0 is 3k, and r of 0 is equal to 4j. And so IVP is short for initial value problem, so we're given some initial conditions here. We're given an initial speed of 3k, and we're given an initial position of 4j. So if we want to find the first derivative and we have the second derivative, we're going to integrate the second derivative to find the first derivative. So we're going to integrate negative 4 cosine t, and that's the j component, minus 3 sine of t, and then that's the k component, dt. Okay, so that's going to give us negative 4 sine of t, and that's our j component, plus 3 cosine of t, that's our k component, and then plus a constant of integration. And then we're going to use our initial condition, r prime of 0 is equal to 3k, to find the constant of integration. So negative 4 sine of 0, and that's your j component, plus 3 cosine of 0, that is your k component, plus constant of integration is equal to 3k. Okay, so this is going to give us that 3k plus the constant of integration is equal to 3k, and then we would solve this for the constant of integration c. In this case, the constant of integration is going to be 0, so sometimes that happens, and it happens here, so the constant of integration is 0. So our first derivative is going to be negative 4 sine of t, and that's your j component, plus 3 cosine of t, and that's your k component. Okay, to find the original function from the first derivative, we're going to integrate the first derivative. So we're going to integrate negative 4 sine of t, and that's your j component, and then plus 3 cosine of t, and that's your k component, dt. And so when we integrate this, we're going to get 4 cosine of t, and that's your j component, plus 3 sine of t as your k component. And then we get a new constant of integration, so plus c. And then we're going to use your initial position is 4j, so r of 0 is going to be 4 cosine of 0, and that's going to be your j component, plus 3 sine of 0, and that's going to be your k, plus c, and then this is going to be equal to 4j. Okay, so we're going to solve for the constant of integration. So we're going to have 4j plus c, your constant of integration, is equal to 4j. Solving this for the constant of integration, again, it happens to be 0. It doesn't happen every time, but our constant of integration is going to be 0. And so now we have our original position function, which is 4 cosine of t, and that's your j component, plus 3 sine of t, and that is your k component. Okay. All right, so we got one other topic to look at in this section. Okay, and so I'll fix some typos in the notes there, so I'm going to erase, oops, wrong thing here. We're going to erase some unnecessary words. Okay, so definition of a unit tangent vector. If C is a smooth curve represented by r, the vector value function r, on an interval I, then the unit tangent vector, big T of little t, is defined as big T of little t is r prime of t over the magnitude of r prime of t, provided that r prime of t is not the zero vector. So we can draw our vector value function r of t, and then we have our unit tangent vector. Okay, all right. Now the definition of a principal unit normal vector, if C is a smooth curve represented by the vector value function r on an open interval I, and if the unit tangent vector is not 0. Well, actually, it's the derivative of the unit tangent vector is not 0. And finding the unit tangent vector is going to be kind of a pain. If it's not 0, then the principal unit normal vector is defined as n of t is equal to big T prime of t over the magnitude of big T prime of t. And so this is the unit vector of the derivative of the unit tangent vector, and so that's going to give us the principal unit normal vector. So that's going to kind of point in the direction that you're curving towards. So remember when we did that circle, and then we had the tangent, and then we had the normal. So the normal is going to kind of point to which direction you're going to be turning, and then the tangent's going to be the tangent at the graph. So you can think of that as the speed. Okay. Alrighty, so we're going to do 2 examples of finding the unit tangent vector and the principal unit normal vector. Okay. Alright, so given r of t is equal to ti plus t squared j for t greater than or equal to 0, find the unit tangent vector and the principal unit normal vector. And then we're going to evaluate each of these at t is equal to 1. So, first thing we need to do is we need to find the derivative of r, which is going to be I plus 2tj. And then we need to find the magnitude of this. And the magnitude is going to be the square root of 1 squared plus 2t quantity squared under the square root. So that's going to give us 1 plus 4t squared under the square root, and that's going to be the magnitude of r prime of t. Later on, we'll call that the speed. Okay, so the unit tangent vector is going to be equal to r prime of t divided by the magnitude of r prime of t. And so that's going to be equal to I plus 2tj all over the square root of 1 plus 4t squared. Okay, now they want us to find the unit tangent vector evaluated at 1, so it's going to be I plus 2j all over 1 plus 4 times 1 squared, which is going to be the square root of 5. Okay, so that wasn't too bad. Okay, what makes this bad is we got to take the derivative of this and then find the magnitude of that to find the principal unit normal vector. So that's where the bulk of the work is going to be on this problem. So t prime of t, we're going to use the quotient rule, so it's going to be the low function 1 plus 4t squared to the 1/2 power times the derivative of the top, which would be 0i plus 2j, minus the top function I plus 2tj times the derivative of the denominator, which would be 1/2, 1 plus 4t squared to the minus 1/2, and then times 8t by the chain rule, and then all over the denominator squared, 1 plus 4t squared squared. Okay, so we're going to factor out a 2 out of both of the terms up here. So we're going to factor out a 2, and then we're going to factor out the lowest power of 1 plus 4t squared, which would be 1 plus 4t squared to the minus 1/2. So we'll factor that out. So 1 plus 4t squared to the minus 1/2. So when we do that, we're going to have 1 plus 4t squared, and then that's going to be a j component. And then we're going to have minus 2t times I plus 2tj, and then that's all going to be over 1 plus 4t squared, and then squared, so that it would just be 1 plus 4t squared. Okay, simplifying this further, this is going to be 2 and negative 2ti, and then plus j, all over 1 plus 4t squared, and then to the 3/2. So this came down as a positive, and so you add that 1/2 to the 1, and by that I mean the exponent becomes positive, so the negative 1/2 becomes a positive 1. So add that to the 1 on the bottom for the 1 plus 4t squared. Its exponent is 1, and that makes the 3/2. Okay, and now we get to find the magnitude of this. So the magnitude of t prime of t is going to be 2 over 1 plus 4t squared to the 3/2 squared, so that's the I component, plus the j component. And they have this part in common, so I can factor that out. And so I'm running out of space here, so I'm going to factor that out. So technically you'd have this times both of these guys here, but I've already simplified that a little bit. Okay, so now we can take the square root of the square part, and we get 2 over 1 plus 4t squared to the 3 halves, and then times the square root of 4t squared plus 1. So when we're finding the principal unit normal vector, it's going to be the derivative of the unit tangent vector divided by the magnitude of the derivative of the unit tangent vector. So that's going to be the 1 plus 4t squared to the 3 halves divided by 2 and 4t squared plus 1. So this right here is the magnitude. That is the magnitude of the unit tangent vector, derivative of the unit tangent vector. So that would be in the denominator, so we'd flip it over just to facilitate how much time we have left, or how much space we have left. And then we got the negative 4ti plus 2j all over 1 plus 4t squared to the 3 halves. And so that is your derivative of your unit tangent vector. Okay. And then notice the 1 plus 4t squared to the 3 halves will absorb, and then we can also absorb a 2. And so we have negative 2t plus 2ti plus j all over 4t squared plus 1. And so that's your principal unit normal vector. And then if we evaluate that at 1, that is going to be equal to negative 2 plus j over the square root of 5. And that's your principal unit normal tangent vector at 1. So there's a little bit of a trick that we can do if we're in 2D. So if we have uv, okay, is your unit tangent vector, then negative vu or v negative u would be your principal unit normal tangent vector. So we could do a little bit of a trick. So notice that here's the I and the j components. Notice that they are switched. The coefficients are switched, and then one of them is the opposite sign. And then you can also use the fact that if you dot product uv with negative vu, you would get 0, which would indicate that they're perpendicular. So the principal unit normal tangent vector and the unit tangent vector are going to be perpendicular, which means that their dot product would be 0. And likewise, you could do the dot product with uv and v negative u to get dot product of 0. So that's a little bit of a shortcut. If you're doing this in space with 3 ijk, you can't do that trick. You just have to brute force it the long way like we did here. Okay, all right, I got one more example here. So we're going to be given the vector value function for r of t, which is 4ti minus 2tj, for t greater than or equal to 0. We're going to find the unit tangent vector and the principal unit normal vector, and then we're going to evaluate each at t equals 1. So we'll find the tangent vector, which would be 4i minus 2j, and then we'll find the magnitude of the r prime of t, will also be the speed. So this will be 4 squared plus negative 2 squared under the square root. It's going to be the square root of 20, which is 4 times 5. Square root of 4 is 2, and square root of 5 will stay square root of 5. So the unit tangent vector is going to be r prime of t divided by the magnitude of r prime of t, which is going to be 4i minus 2j over 2 root 5, which is going to simplify to 2i minus j over the square root of 5. And that is a constant, okay? That's going to be a constant. So the unit tangent vector at 1 is going to be that. It's constant. So the unit tangent vector is going to be 2i minus j over the square root of 5. Okay, so what this would mean is if we graphed this vector value function, it would be most likely the graph of a line or the slope of the tangent line is just going to be constant. It's going to be the slope of the tangent line. So it's not going to be turning left or right, so that would be an indication that the principal unit normal vector would be 0. And when we do take the derivative of the unit tangent vector, we do get 0, and we can't get the principal unit normal vector because it is the derivative of the unit tangent vector divided by the magnitude of the derivative of the unit tangent vector. And since the unit tangent vector is 0, its magnitude would be 0, and so we'd have a 0 to 0, so we wouldn't be able to do that. Okay. Alrighty, we'll stay tuned for section 3 of chapter 3, so that'd be 3.3.